All right, so my name is Nate Riehl,
My name's Maneri.
and this is our presentation on the bucket sort algorithm. So, just to introduce it, what exactly is it? Well, it uses a combination of different sorting algorithms to sort your data. So it does this by sorting all the data into buckets and then sorting each bucket individually using a different sorting algorithm, and then at the end it'll concatenate or combine all of the different buckets together, and that will give you your final sorted data. So let's do a visual illustration of how this works. So this is our sample data here. We have an array of integers. So we have 4, 3, 1, 2, 6, and 5. So we're going to split all the data up into two different buckets. The first bucket is going to hold all the values from 1 to 3, and the second bucket is going to hold all of the values from 4 to 6. So when we do that, going from left to right, we have in the left bucket 3, 1, and 2, and in the right bucket 4, 6, and 5. Then we go bucket by bucket and use a different sorting algorithm to sort all of the values in each bucket. The first one becomes 1, 2, 3. The second one becomes 4, 5, and 6. And then after that, we can concatenate the two buckets and put them all into a new array, and that'll be our sorted data set. So here, again, 1, 2, 3, 4, 5, and 6 coming straight out of the buckets that we just sorted. So I want to talk a little bit about time complexity of the bucket sort. So it's kind of tricky when we talk about this because it depends on which sorting algorithm we're using for sorting the buckets. So let's just assume that we have an inefficient sorting algorithm. Doesn't matter what it is as long as it's efficient. So best case scenario, we know that the time complexity will be O of n, and that's where the data set is already sorted. Worst case scenario is going to be O of n squared, and that's when all of the data is placed into a single bucket rather than distributed across multiple buckets. And then lastly, the average case is going to be O of n plus k, where n values are distributed uniformly into a number of different buckets. So, what type of data can be used, and when is it going to be most efficient? Well, it's going to be most efficient when our data is uniformly distributed. What does that mean? That just means that when we have a data set, say this one here, 8, 4, 6, 12, 2, and 10, that means we can split it up into different buckets evenly. So the first bucket is going to contain the values 4, 3, and 2, and the second value is going to contain, the second bucket is going to contain the values 8, 12, and 10. So in this case, we have 3 values in each bucket, meaning that it is uniformly distributed. Now I'm going to hand it over to Alex to talk about what happens when it's not uniformly distributed.
So as you can see, this data is not uniformly distributed. If we have two buckets of ranges 0 to 5 and 6 to 12, this results in almost all the values being placed in the first bucket, with only the value 11 placed in the second bucket. This makes our algorithm very inefficient. So the pseudocode for bucket sort, first you're going to create n empty buckets or lists, depending on the size of your array. Then for each element in your array, you're going to place them into their corresponding buckets. Then sort each individual bucket in either ascending or descending order. And then at the end, concatenate all the buckets. You have one large sorted array. So stability, bucket sort is a stable sorting algorithm. This means that when you have values that are the same, in this case our array, 5, 6, 5, 5, the values that are the same, 5 in this case, will remain in the same order relative to each other that they were originally. So the end result of this sorted array will be 5, 5, 5, 6 in the same order, as you can see the colors that they were originally. So in place, bucket sort is actually not an in-place algorithm. This means that extra space is required during the sorting process. So for this array here, 3, 1, 7, 4, 8, 2, 6, 5, in this case we actually have 2 additional buckets, which are arrays, to sort the values 1 through 4 and 5 through 8. So half the values are placed in this bucket, half are placed into this bucket. Those 2 extra buckets require a lot of extra space, making this not an in-place algorithm. The space complexity for the bucket sort is O of n plus k. N is the number of elements to sort, and k is the number of buckets. Cool facts: bucket sort can handle duplicates very well. It's very easy to understand, the algorithm, and it works very well with floats. Thank you.
That's about it.
PowerPoint description.
Yes.